Hey there! We got a fun one for you today. We're going to be making these procedural tentacles, exploring some modeling techniques, rigging techniques, animation techniques, and maybe a little bit of texturing and rendering. Let's go! Okay, so here we are in Houdini. This was a fun experiment to work on. I'm wanting to do something with some octopus tentacles for a project, and I was looking back at a lot of my YouTube videos. I feel like I have a lot of just weird cylindrical object tutorials. I'm not sure what the deal with that is, but I remember about probably like 13 years ago at this point, when I was first starting 3D modeling and animation, I wanted to make a squid, and I did traditional hard surface modeling and rigging in Maya, and that was quite a challenge for me. So this is sort of nice to revisit a similar setup here in Houdini, a decade later, and see how much faster this was compared to when I first did it. So I'm going to walk us through this setup. I'm going to start with the modeling aspect of it, and then we'll move into KineFX setup, heavily inspired by CG Wiki, Matt Estella's stuff. So let's go ahead and get started here. So we're going to be recreating something like this. I'll recreate some of the node structures if I think it needs some further demonstration, but we have essentially what's completely procedural setup here. We can control the number of tentacles here. You can control the length and stylings of this. I just have like a simple color shader on it. So this is going to be 12 tentacles here. We can adjust the shape it's scattered on. Maybe I won't clip this. Let's try this look just for fun. And this is very much like that Matt Estella KineFX setup with just lines, but applied to octopus tentacles. But it has a lot of customizability. So the very first step here is we actually have to model a single tentacle, essentially. And to start with that, I started with a line here. I added a resample node to get some more subdivision to that line and generate this curve U attribute. And then I used a point VOP to create P-scale. So in my previous tutorials, the lava lamp and the freaky organic growth, I go a lot into point VOPs. But if I double click and dive inside this, very simply, I just have the curve U routed into a ramp, and that's getting routed into the P-scale. So that just lets us control the thickness of that tentacle. So I'm gonna, this branches off into two sections, into the suckers on the bottom of the tentacle and then the tentacle itself. So let's take a look at how we create the rough shape in general of the tentacle. Pretty straightforward. I just use a sweep node, and I am routing in a custom profile curve to get this sort of squashed half cylinder shape. So I'm just using a circle here, and I'm editing those points just to make sort of the rough cross section of the tentacle, feeding that into the sweep node, and we have the basic geometry. This P-scale node here is what's driving that thickness. So we can use that to modify the thickness of your tentacle, and you could also adjust the length of this if you wanted a longer tentacle or different sort of looks. So main things to be looking at is the length of the line and the P-scale, as well as this cross-section shape. Okay, so then I didn't end up using this, but I was playing around with maybe having like a low poly thing I might export to different software. Here I was just doing a little bit of coloring, so I just grouped the faces on top to give it a red color and faces on bottom to get a green color. I didn't really end up using this You could use, UV this and texture it traditionally if you wanted to. I ended up just doing all procedural texturing, which we'll go over in a little bit here. But there you go. You got a rough sort of tentacle shape here. Now onto the suckers. So the idea for the suckers is we are going to use this baseline as the points to scatter or copy the suckers on. So right here I made a very primitive geometry for a single sucker. If I double click, this is just a subnetwork to stay a little more organized. All that's going on in here is I'm using some traditional poly modeling tools. So I just take a tube, I do a few extrusions here. This isn't really procedural. I wasn't really interested in changing the sucker shape. I just wanted to make one. This is very much like if you modeled it in Blender or Maya or wherever. If you didn't know, you can model in Houdini just like any other 3D software. So if I set my context menu to something like poly modeling, I can press S to get into selection, make something like an edge selection, press C to get my little tools, and do poly extrude. And I can just model just like if we were in any other application here. I would say it's not as sort of streamlined. Like I don't necessarily do a lot of modeling like this in Houdini, but it's nice if you just want to have something small you're modeling and not want to jump into other software. So totally possible to hard surface model. You'll just end up with this sort of messy node tree at the end of it. But that's all well and good. So here's my primitive sucker with some extrusions, and I did the same coloring just in case I wanted to use something with a mask or a color ID map. Ended up not going that direction, but there you have it. So what I did was I took one of these suckers, moved it over a little bit and mirrored it. So we actually are copying the pair of suckers per point on the line. I subdivide that just to get a little bit smoother of a result. I did a little remapping of this, which I ended up not even using, so you can safely ignore that. And then I have a final transform node just to make these a bit smaller. And here's where I had the discovery of a new node I've never used before that is quite handy. So I'm going to disable this for a second. So by default, this is how a copy to points would look on that curve. So I'm going to go ahead and look at both of these at the same time. I ran into this problem where as these suckers get smaller, you want more of them. So you want a higher density of those further down here on the octopus tentacle. If we're just using the piece scale with the points on the curve, it works. It scales them downward, but we lack that higher density here. I was looking at some different ways of accomplishing this when I discovered there is this curve resample by density node, which is pretty cool. So this is the first time I've actually used this node. If I display the point numbers here, and I'm just disabling this just so we can see one at a time. When you put down this curve density, you're able to specify the number of segments here, and you're also able to remap the density of the segments along the curve. So you can see as I move the density down here at the top of the curve, we get these points further apart. If I increase the density at the base of the curve, we get, or sorry, at the end tip of the curve here, we get more points down there. So it's quite applicable in this situation. So let's see how that looks with the suckers copied. That's looking pretty good. But I decided not to use the exact piece scale from the curve. I wanted a little bit of control over the size of this. So I just remade the piece scale attribute on the suckers here just to scale them a little bit differently. Very minor change here if we see before, after. I just wanted to get a little more girth to these suckers at the the base of the tentacles here. And there you have it. So you have this sort of medium density model of a single tentacle here. Now you could definitely just use this geometry as is and throw it into a rigging setup and get some animation. I wanted a little bit more organic sort of flow to the geometry, so I leveraged some of Houdini's VDB tools. Those were also featured in the last couple tutorials to make a more organic shape here. So this process combines all this geometry. You could think of it like an advanced Boolean operation. I use a VDB from Polygons node set to a surface VDB with a pretty low voxel size. You would have to adjust that based on the size of your mesh. And you can see that combines everything into this continuous VDB shape. And then I use some of these smoothing operations. So I use the Gaussian smooth SDF, which really sort of softens the whole mesh quite aggressively. And then I followed it up with a mean curvature flow smooth SDF. And you can see in this case, I lost a little bit of like details. So some of these suckers at the end, they have less of that like indentation to them, but I didn't mind that. You could play around with these smooth operations. If I disabled the Gaussian one, you can see I retain a lot more detail. Depends what look you want, but now I have one continuous mesh here, or not mesh yet, one continuous volume, and I can use the convert VDB node and set that to polygons to convert this mesh back to geometry. And you can see right now it's pretty messy, pretty high poly. I went ahead and I tried the new quad remesh node just to see how nice of a result that would give me, and it was not bad. If you were to do this, I'm sort of just doing this quick and dirty just to as an experiment, really. If I really wanted to make like a whole creature octopus, I would take some time at this point and make this mesh a little bit better. But you can see here, still not bad at all. And you could certainly bake your details from your high poly mesh to your quad remesh and have more of a standard sort of high poly, low poly baking workflow. I didn't go into all that for this, but it's something you could definitely explore. So after that, this is where I kept going back and forth, like where to do the attribute creation. I just wanted a couple attributes to designate the top and bottom of this for shading. So I went back and did something similar that I was doing up here. This is why I didn't end up using this stuff. I just recreated it down here. So I just use a group node to select the points by normal. So I just checked on keep by normal and set the direction to 1. And that's a nice quick way to just select any points that are pointing up, and I can use the slider sort of as a sensitivity for that angle. And then I use that just to create those colors. So I have red sort of on the top faces. I blurred that out a little bit. And I use that in the shading. Once again, you could UV it, you could texture it, you could do whatever. But this is what I did. The one thing I wanted to do is have a little selection of the interior sort of recess of the suckers. I added like a slight glow to that in the final render. So this was a little bit of a hacky way of doing this. Remember back here I said I didn't use this sucker attribute remap thing. I had made this attribute to designate this inner part of the sucker when I did the modeling, but since I ran all of these VDB smoothing operations, my plan was just to attribute transfer that back onto this mesh. But the the actual silhouette of the mesh has changed too much. So you can see we lost a lot of volume with that Gaussian smoothing. So I couldn't directly copy that attribute back onto this mesh. Sorry if I'm losing you guys with this little section. This is just a little, there's always those little gotchas. So this is just a little extra thing I wanted to throw in here. So what did I end up doing to get this little color back? Well, I went back and I split off my original geometry before the smoothing operations. I used a blast node and I set that to delete everything without that sucker attribute. So it just kept that little bit of geometry right on the bottom of the suckers. I moved that geometry downward a little bit. So I just use a transform node and shift it downward. I set a normal attribute to point straight up. So that's all this attribute wrangle is doing. It's setting that normal direction. I could have just done an attribute create as well and typed in N for normal and set that value just to straight up on the y-axis. And I can feed that into a ray node to project that back onto my mesh. So you can see that is just matching up. Let me hide the guide geometry. So we have all of our suckers. If I template this, you can see before the ray node, they're way down here. And then when I ray them, they pop back up right where the little indents of the I keep saying suckers. I feel like I'm saying that word too much, but I don't know the technical term for what those are called. Maybe someone can let me know that. And then, since now they're right overlapping on the mesh, I can use that attribute transfer and transfer that sucker attribute back onto my remeshed VDB Tentacle. And if I preview that, you can see we have that little indication. Since my geometry isn't perfect, we get some sort of anomalies. I just blurred it out a little bit, and that worked just fine. It's a little janky. I will admit it. If you wanted to do this correctly, I would just have nicer geometry and transfer the attribute. But in this case, I actually didn't mind. I like the little inconsistencies and blurriness to this. I think it worked with the effect I was going for. Lots of different ways to, I was going to say skin a cat. I was trying to think of a equivalent like octopus way of saying that, but I couldn't. Anywho, there's your final tentacle. So this is the final mesh. I'll turn that off. It has some color and attributes we can use in shading. Now let's look at how we can use that in a KineFX rig setup to get this to start bending all around. Okay, so let's give a brief primer about rigging in Houdini and just rigging in general. So if you're a complete newcomer to 3D, in order to animate a character or a mesh, you usually add a rig to it. So the rig is referencing the bones and the joints inside of a character, just like you're a real life human with bones that allow your skin to move. You have a similar setup in 3D. So your rig is your skeleton with controls that lets you move your geometry. So that's pretty much standard across many different 3D applications. There might be a little bit different ways of making it. And in the last couple of years, Houdini has really revamped their rigging methodologies with KineFX and Apex. The way rigs work in Houdini is a little different now, and it's actually really cool. So in order to have a rig or have something animate in Houdini, you essentially need three things. You need a mesh, which could be any sort of geometry. You need a skeleton, and this is where it's a little bit different in Houdini. Instead of having like dedicated joint nodes, we have a lot of KineFX nodes that essentially make joints, but instead of having like a data type labeled as joints, skeletons and joints in Houdini are just points and lines. So points are your joints and lines just dictate the hierarchy, the relations between those joints. That really opens up a whole interesting world because anything can really become a rig. Any line, any points can become a rig, which is quite powerful. We'll see how we're using that in the tentacle here in a second. And then you need an animated version of that skeleton. So you need those three things: a mesh, a rest skeleton, or your like default pose skeleton, and an animated skeleton, and you can animate then. So let's look at this very simple setup here in Houdini. So the skeleton node here lets you create a skeleton, which is just points and lines. In this case, I'm using that skeleton itself to create a mesh. So this is a little bit backwards to traditional sort of character flows where you usually would make the model first and then add the skeleton in the middle of the model. In this case, I'm making the skeleton first and generating the model directly from that, but either way can work. And so now I have a mesh, a rest skeleton, and I have this skeleton. Whoa, my cat's running around. This skeleton routed into a rig pose node. So if I click enter in my viewport, I can select any of these joints here, and I can rotate those around and move them with the rig pose. And this will function just like a joint hierarchy in any other software, where if you rotate the parent joint, it rotates the children. And then you can throw those three nodes into a joint capture biharmonic. So this node is what actually does your skinning. So for those of you not familiar with skinning, that is the process of actually linking together the internal skeleton with the mesh. So when that internal skeleton moves, it is deforming that mesh surface. So this joint capture biharmonic will do that for you. This is all default. I didn't change anything. And then to actually see the animation applied from this rig pose, you have to lay down this joint deform, which actually applies the animation. So if I go back up to this rig pose now and I adjust rotations, woo, you can actually see this is now bending this mesh when I adjust that rotation. So I could click this in the viewport and then use the gizmo to rotate it, or I could just rotate it with the UI over here. And just to show you, anything can become a rig. So if I made a line here, this is basically the backbone of our tentacle example in a second here, and added 3 points, so just like an arm. So you have a shoulder, an elbow, and a wrist. And I plug this into this setup. So I'm just going to plug this line into the place of the skeleton. And I'm just going to reset this rig pose just because this has different names. You'll see by default we get an error. That is because we need a transformation attribute on each point. So notice if I click on the info for the skeleton, we have this local transform and name attribute. So that is pretty important for the rig to work. We can add those attributes with this rig doctor node very easily. So if I just plug this bad boy in between here, I can then go ahead and check on initialize transforms. And this node is just an easy way to start or initialize all the attributes that the KineFX system needs. And now we're good. We have the same setup. I can go to this rig pose, hit enter, and I can do the exact same thing. And you can see this whole thing is just driven by a line now. So I can adjust the length of that line. I could adjust the number of points on this line. Let's set it to 6 points. And then I'm going to go back to my rig pose here. And I can now adjust these rotations of all these points. So now you might start to understand or connect the dots of how the tentacle will work. We have a line getting fed into this rig system, and it is basically auto-creating this rig based on the points in that initial tentacle line. Now you could get more advanced with this. This technically isn't really a full rig with controls. We're not generating any like curves that an animator can use. But you could certainly take it to that next level if you wanted to. Apex isn't my specialty, but there's a lot of good content. I'll link some going over Apex rigging. So let's jump back out of this and go back to our octopus here. So in order to get some more tentacles, you could run this whole setup on one tentacle, but it's nice to have more, right? So before we do any sort of rigging, I go ahead and I copy that tentacle to just a bunch of points. So let's sort of break this down a little bit here. I'm going to kind of organize this so it makes a little more sense. So what I'm doing here, just to give you an overview, is I'm taking the original curve. So this is just for organization, but I'm just referencing this in curve right here that we use to make the whole tentacle. And I'm copying that to some points. This, you could do as many as you want. So I could scatter more points here. All I'm doing, let me walk you through this. I take a sphere. I initialize a normal attribute. I'm clipping the sphere. I'm scattering some points to the top of it. And I add an ID attribute just to vary stuff down the line. And now I have a bunch of lines, which are essentially my tentacles, copied to points. So you could generate those however you want. I could make a box, for example, and just copy a bunch of tentacles to a box. That could be kind of an interesting look. But I'm just going to keep it the same here. And that's the basis of your rig. So I'm using the copy to points with the original line here. So this in curve. And adding a rig doctor just like we did before. And then that is the rest skeleton. To make the actual mesh that's going to get deformed, I take one of those tentacle geos with that VDB smoothing that we performed here, and I copy it to the same exact points. So here's my mesh. Here's my rig, mesh rig, in the exact same location. They're all the exact same length because they all are created from the same original line here at the very start. So then we just need to animate. So I'm going to just I'm going to disable these nodes and explain that in a second. I'm going to add a rig pose here to the rig doctor and plug it into the anim skeleton. And I'll put my view flag here right on the joint deform. And that will just take a second to initialize the skinning the first time you put your visibility flag there. And now I can go to the rig pose, press enter. Here are all the joints. I could select a bunch of these at the same time, for example. Ooh, nice. And now I could animate this sort of more traditionally and kind of pose this out in different ways and create a keyframe animation with that rig pose. That would be one way of going about this. But that's not very procedural. If I wanted to kind of have this slithering in a very specific way, that is definitely how I would go about it. But for this, I reused, as I mentioned, a setup from Matt Estella on CG Wiki. So this is pretty fun, where we actually use a rig attribute wrangle here to add procedural movement. So when I plug this attribute wrangle in here, it is automatically moving these curves in this nice sine wave manner. So let's break this down. So this gets a little more technical because we are using a little bit of Vex here, but it's not too bad. So I'm going to try to explain this as simply as possible. So essentially what we're doing here, let me make this a little bit bigger and easier to see. I'm taking each joint here and rotating it. And the amount of rotation it gets is based on the curve view attribute that we generated way at the start with that resample node. So that's curve view was generated way back up here. Second node we put down and we checked the curve view. So what this does is the higher the curve view value, so if I just visualize curve view right here, turn on my visualizer, you can see the 0 to 1 here. So the higher that value is, the more it'll rotate. So let's go back and look at this this vex. So I'm gonna ignore all this. I should have commented, put some comments on this before I went over it. But let's look down right here first. So the way we can rotate something with code is in a rig is by using this rig attribute wrangle, and you can use this rotate function. So what this vex function does is you take the local transformation matrix. So that is what this is. So this is just that attribute that the rig doctor initialized. So it's just the rotation and position of those joints. And then you can apply an amount of rotation and the axis that it's rotated on. So this basically takes two variables here that determine how bendy these tentacles will be. You could put in anything for this. So I'm going to just comment out this top for a second just so we can experiment with this. So if I redeclare these attributes, I'm going to just do float amount equals 15, let's say, and then I'll do vector axis equals, let's do set to set it and set it to y. And I'll put my display flag on the wrangle. You can see here, let me just set this to 1. You can see here we now are rotating the lines equally on every point. And right now it's set to radians, I believe. So 1 is like a lot of rotation. So if I go ahead and make a radians function, just so this is a little more easy to see, and set this to something like 90, so like 90 degrees, or let's do 10 degrees. Now we have this sort of subtle rotation along the whole bend. So if I type 15, each joint will rotate a little more. If I do 25, each will rotate a little more. And you can see once I get too high, it'll sort of get super, super frizzy because we're rotating too much. If I wanted to rotate on a different axis, I could go ahead and set that here, and you can get these interesting spiraling shapes. All right, so let's delete that and uncomment this. So instead of manually setting those values, we just procedurally set them with the time of your animation. So I'm making a float called time, and I'm setting that to time, which just returns the time of your playback here. And I'm offsetting that per tentacle. So I just generate a random value per tentacle. So we had that ID value we had made back up here with the enumerate. And then I use the sine function and multiply that against curve view. So that's that 0 to 1. So the more towards the base the joints are, the less they rotate, and the more towards the tip they are, the more they rotate. And that is generating the total rotation amount. The axis I just set to a variable here, so I created my own axis variable. You can use that syntax chv axis to generate that. Just to show you how to do that, if you type chv for channel vector, and I could type in arbitrary vector. I butchered the spelling, arbitrary, that's fine. And then I use this little initialize button right here. That'll create that additional parameter, so you can use this. And I'll go ahead and delete that. And so now I can set the axis that these rotate on. So if I just wanted Y, I could do that. If I just wanted X, I could do that. You could animate this. You could do whatever you want with it. I'm using a little multiplier here to multiply how much these are rotating. This could be interesting for something like plant growth, like a fern unfurling. You could do this in like a field of ferns and reapply this whole setup for something like that. Pretty great, pretty powerful. No keyframe animation required. But that being said, you can certainly apply keyframe animation on top of this. So I'm going to undo and get back to where I was. And I'm going to input these two nodes back here. I'm using a curve remap just to kind of control the fall off of that rotation. So this attribute remap set to curve U just gives me a little more finesse on how bendy it is on the top versus the bottom. If I didn't want the bottoms bending at all, I could manipulate this curve so I get only that rotation at the top and it has more of a static bottom. Go back. And I'm walking through this more like of a show and tell walkthrough rather than recreating everything from scratch. If you like that method, let me know. If you prefer like each node individual one by one, let me know and I can do more of that in future tutorials. But just to show you, you can combine this automatic rigging with this rig pose. So what I noticed is, let me go ahead and show the joint deform. I noticed when I was doing just the wrangle, I was getting some intersections here. So notice that this tentacle sort of intersects itself when it's animating right here. So I added a rig pose just to adjust those points manually and set a few keyframes so I no longer have intersections on that tentacle. So you can totally combine like procedural workflows and keyframe workflows and layer those on top of each other for different effects. And that's the whole setup here. At the very end, I just put a point velocity node to generate the velocity for motion blur when rendering. But there you have it. I have a fully functioning skeleton tentacle skeleton rig. So pretty cool. Just trying to think how much time do we have? Do we want to do a quick rundown of the materials here? 5:05. I don't know how long have I been recording. Maybe I should cut that out. Let's do just a quick rundown of the rendering of this. So I'm going to jump over to the stage here. So I have a lot of tutorials, especially the worm milk tutorial I'll link that goes over procedural shading. I will link that in here, but I'll just do a very brief overview of how I did the materials and lighting of this. So for the materials, I bring in the octopus tentacles with a SOP import onto the stage. I made a material library, assign material, all that is basic. Let's dive in and look at the specifics of how this material is made. So it's a little messy here, but just to give you an overview, I'm essentially just using the rest attribute. So I put a rest attribute on the original mesh. So if I jump back over to object, I'm adding this rest attribute after I copy it to points. If you had UVs and had textures, none of that, you would just texture it normally and apply your textures. But in this case, I use rest to generate a little bit of noise variation. And then I combine that with the display color, which just designated the top and bottom of the tentacles that we had gone over, to drive how much subsurface scattering this has. So a lot of the nice tentacle look comes from the subsurface scattering. So the base of the tentacles here. So we have no lighting here, but the base of it has this very fleshy look, and then the top has more of a non-subsurface snake look almost, with a little bit of bump mapping on there as well, normal mapping with that noise. And when you actually see that with lighting, let's go ahead and add this light back in here. It starts to look something like this. This looks awful because a lot of the look of this is changing with the volumetrics. But just to give you an idea, that's how the base sort of material is looking. Just a note, I am bringing in that sucker attribute and piping that into emission and adding a little bit of emission color. So if I really boost that up, you can see that adds that little bit of glow on those suckers. You could even animate that or do some interesting things with that as well. And then I'm adding classic Karma Fogbox to get a little bit of atmosphere in here. And for this one, I did a lot of heavy lifting with the Karma lens material. So if I jump into the camera here and take a look at this, I added some curvature. I tinted everything. I heavily adjusted the exposure of everything. There's basically a lot of post-processing going on in here on this Karma lens material, which is pretty nice to play around with. If I click on the Karma lens material here, I'll turn that on and off. Maybe we can see a difference. Let me just go beforehand. So here's before that. Here's after. It wasn't refreshing. So here's before. We have more of this sort of orangey red look. Use lens shader. I'm going to have to click restart render because it's not automatically updating when I click that. And you can see the look changes quite a bit. I didn't have the emission set too high here. It was probably set to something more in this. Where is that? More so in this ballpark, just as a little subtle glow. So you can see without emission, you don't get that glowing look, but lots of iterations for this. I used the snapshots a lot. That's a great way of iterating. So going through different looks and color patterns and finessing this and adding glows. All that was brought into a COP network to add some denoising and some finishing touches on it. And then you get the final render. Lots of rooms for stylization for this. You could use this whole setup and bring it into something like Blender, for example. Add some line art to it. You could do the raw low poly mesh and make some fun low poly artworks with it. You could, if you wanted to make a whole octopus character, you could apply this same workflow, but then mesh in something like a sphere, for example. So if I go back all the way back here, I could add more objects to the mesh and combine it with the VDBs to make some interesting creatures. Sky's the limit, right? Hopefully this gives you some ideas, some direction. I'd love to see if anyone does some different stuff with these techniques. Let me know if you have any questions. This was a little bit different format, just sort of me talking to the camera informally. Let me know how you felt about that. And have a great week, and it's Memorial Day weekend. have a great weekend. Hopefully you're watching this on the holiday. All right. Talk to y'all later. Bye bye.